Next, we come at the most important parameters of pharmaceutical powders, that is the flow properties of powders. If your powders have less flow properties, so you can get difficulties during compressions and filling of powders in any instruments or any device in this process. It is the flow properties of powders. Individual powders have different types of flow properties which can be induced and which can be reduced by additions of different types of excipients. Here we can show that some divisions is there, that commonly manufacturing problems is attributes in the powder flow. That is the uneven powder flow. That is the uneven powder flow is the excess entrapment air within the powders. It is called the capping or laminations. Capping or laminations means when you compress a tablet, that time the tablets are separate in different types of layer. Layerly it is different. So this is due to the presence of excess amount of air in between the powders. So that time the capping and lamination is called. The excess amount of airs is present due to the presence of excess amount of void space and porosity nature in between the powders. So excess amount of porosity is present in this powder, so that time the excess amount of air entrapment in between this process. So during compressions the air is try to come out from the porous or void spaces. So that time it is break it or it laminate the tablets in different layers. Next is the increase the particle frictions with the dye wall, causing the lubrication problems. So what is lubrications? Lubrication means additions of lubricants, addition of glidants, which increases the flow property of powders. So in this process you can adjust it the less amount of glidant of lubricant or higher amount of glidant of lubricants, so that causes your flow property of powders affected by the additions of unequal quantity of glidant and lubricants. So these flow properties of powders we can determine different types of process. First one is Carr's index, next one is Houston ratio, and most popular techniques is angle of repose. The one of the main reasons of the entrapment of air in these particles, excess amount of moisture in this process, which can getting frictions in between particles, surface roughness and the irregular surface of particles. If you have sphere particle which have greater flow properties than the irregular particles. Irregular particles make a friction in between particle and get locked in between the particles, so that's why the particles not freely flow in this process. First here we come in the most popular process, that is the angle of repose. Angle of repose, in this process the maximum angle possible between the surface of heap means, so when you particle put on a surface, that time it's appeared like a heap or cone. This cone or heap or pile, it is the maximum angle, possible angles in between the heap or pile of a powder and the horizontal plane. In respect of horizontal plane, that heap or pile is appeared, that's maximum possible angle. We can calculate it by the angle of repose. It helps in quantifying the frictional forces. During process, the particle frictions when increases, the pile of the height is decreases, and particle flow is good, freely flow, that time the heap or pile is increases. So that is difference between the flow properties, regular flow properties and irregular flow properties. So the frictional forces mainly contribute the improper of the flow powder, that is defined by the equations tan theta equals to h by r, where h is the height of the pile and r is the radius of the base of the pile. The base of the pile when you take the powders and make a setup ready with a measuring funnel, and funnel is blocked with some cotton or tissue, and that time you can fill the powders and by on the funnel and release the cotton or tissue paper and allow the powders to freely flow on the surface, this horizontal surface. That's make a heap or pile, and you can get a diameters of the pile. So you can average diameter divided by d by 2, you can get the radius of the base of pile. So this is the exact setup. So by this setup you can addition of glidant to increase the flow properties, accordingly increases the gliding parameters. When you add in the 1% of glidant, that time you get one angle of repose value, 2%, that time accordingly you can increases the glidant concentrations. So that's why one time you can saturated the total glidant process in this powder process, so that time angle of repose value again decreases, angle of repose value again increases. Okay, so angle of repose value if less than 25 in this tan theta equals to h by r process, you can determine the angle of repose theta. This value is excellent. If your value is 25 to 30, this value is good. 30 to 40 is possible. 40 to 50 is poor. Greater than 50 is very few. So at a time when the concentration of glidance is increases, the saturation level is start. So that time your angle of repose value is according to additions of glidance, at a time it is decreases, because your excess amount of glidant is adding in between the powder. So it's this powder or glidant clog the porosity of the powders and clog the porous nature or porosity of the funnel. So that time the particle flow is decreases, heap size is decreases, and the diameter of the pile is increases, and the value of angle of repose is increases. So if your value is greater than 50 is called as a very poor, 40 to 50 is also called as a poor. Next is process is the Carr's index. It is also called as a compressibility index. In this process, we can calculate it. The compressibility force is required to compress particles. That is a Carr's consolidation index. It is indirectly related to the flow rate. If your powder flow rate is better, so its compressibility also better, because its powders have better cohesiveness and the particles, which is directly affect the flow rate of the particles. So a volume of powder is filled into a graduated glass cylinder and repeatedly tapped for a known duration. So volume of powder after tapping is measured. It is a first volume you get, it is a floppy density equals to pore density and the bulk density. So Carr index is calculated by the bulk density apparatus. So when calculate the powders bulk density, and there you can determine the tap density and tube density. Mainly here using the floppy density and tap density. Floppy density is means the first bulk volume, which is called the floppy density. So Carr's index equals to tap density minus floppy density divided by the tap density. That's process we can calculate it, the Carr's index value. Carr's index value in between 5 to 15 it is excellent. If 12 to 16 it is good. 18 to 21 it is fair to possible. 23 25 is poor. 30 is 38 is very poor, and greater than 40 is very few. If your Carr's index value increases, the flow property also decreases. So there are other process to regulate the improvement of flow properties by using altering the particle size. In case of increasing the average particle size of particles improve the flow properties due to reductions of cohesive forces. You can take the average particle size. If you have take the spherical particle size, if your particle size distribution is correct, if your particle size distribution is same, so that time the particles frictions possibility is reduces. So altering which can increases the flow properties. Removal or addition of fines. Each and every granules when you prepared, you needed the 20%, 30% of fine, and less amount of fines is required to preparation of granules. When you compress the particles without any fines, you do not compress the powders, and if you have more fines, so during process you can have capping and laminations in this process during preparation of tablets. So minimum amount of fines is required to compress the tablets, and minimum amount of fines when you add it in the granular mass, your granules process is completed. But when you add the excess amount of fines, but when you prepare the granules, that time prepare excess amount of fines which reduce the flow properties of powders. So improve the flow properties of powder by addition of minimum amount of fines with the granular mass. If you had 80% or 70% granules, you add 30% or 20% of fines. That is exact amount of fine presence in this process. Next is the altering the particle shape and structures. Previously said the particle shape is irregular, so that causes the affect the flowability of powders. So try to take the spherical particles or irregular shape particles by any process, by any instrument or apparatus, you can convert it into spherical particles. Altering the surface forces. Reduction of electrostatic charges on particle surface by reducing frictional contacts. By reducing the electrostatic charge. Electrostatic charge is formed due to the presence of porosity, void space frictions, and excess amount of moisture in this process. So you have to control the moisture contents in these powders by using moisture determination apparatus, and also induce the flow activators, additions of flow activators like glidants or lubricants. In example, some is there glidants you can use previously in laboratory. In starch, talc, magnesium stearate, both are glidants and lubricants as well as. So these types of flow activators and glidants also induce the flow property of a particles.